Welcome to the deep dive. Today we're getting into maybe the biggest mystery left in physics, consciousness itself.
Yeah, it's a big one.
For a long time, a lot of experts just dismissed it, called it philosophical fluff, too messy, too subjective, basically not real science because you couldn't falsify it.
Right. How do you measure a feeling?
Exactly. But the sources we're looking at today, including work from physicists like Max Tegmark, they argue something different. They're saying, look, we might finally be ready to pull consciousness out of that, speculative fog and into proper hard science.
And it feels like a huge shift, but it's not entirely new territory for physics, is it? If you look back historically, pretty much every major expansion of physics got ridiculed at first.
Oh, really? Like what?
Well, think about Michael Faraday and the electromagnetic field, the
Right.
sort of established Newtonian guys. They basically said, hold on, you're talking about invisible stuff, affecting things across empty space. That sounds like ghosts, not physics.
Huh? Invisible ghosts. Yeah, I can see the parallel.
We hear those exact same kinds of dismissals today about subjective experience. How can you quantify that?
And it gets even muddier when you bring AI into the picture, doesn't it? Because scientists seem totally split.
Oh, completely. You've
Yeah.
got one camp saying, basically, intelligence is consciousness. Build a really smart AI, and bam, you've got sentience. Automatically.
While the other camp says, nope, impossible.
Yeah.
Machines, conscious, never.
Hmm.
No matter how clever they get.
Yeah, and they're sort of talking past each other, I think.
Good.
Because they're not even agreeing on what they mean by consciousness or intelligence.
Okay, so that's our mission for this deep dive then. Untangle that knot.
Pretty much. Let's try to clearly separate intelligence, the ability to get stuff done, achieve goals from consciousness, which is the actual feeling, the subjective experience of being.
And then show how physics is already kind of absorbing fields like AI.
Right. And then propose a way to actually test theories of consciousness, make them falsifiable, and crucially, dig into the physics of goals, which is key for AI alignment.
Okay, physics expanding its domain. People often think physics is sort of done, but you're saying it's always been growing.
Absolutely. It started with the basics, right? Galileo dropping weights, simple mechanics.
Then Maxwell.
Maxwell brought in electromagnetism. Suddenly, physics explained light, color. Later, quantum mechanics came along and explained chemistry, why stuff is hard or soft, diamond versus cloud.
So AI, is that really the next step for physics, the internal workings of, say, a language model?
I think so. Look at what modern physics is. It's basically taking a complex system, could be the universe, could be a neural net, and trying to map out how it works inside. Mechanistic interpretability, that's the term.
Mechanistic interpretability.
Yeah. So astrophysics is just applying that to the cosmos, AI research. It's applying it to intelligent systems, like figuring out the structures inside a large language model that let it translate Portuguese into Japanese, for instance. We're using physics tools to understand complex cause and effect.
And we've already seen this work for things we used to think of as purely mental, right? Like memory. The Hopfield network example in our sources is fascinating.
Oh, it's beautiful. It won a Nobel Prize. It gives us a physical model for memory.
How does it work? The source mentioned an egg carton analogy.
Right. Imagine an egg carton. Now think of the vertical dimension as potential energy. The little dips, the valleys where the eggs sit, those are energy minimums.
Okay.
Each valley acts like a stored memory. Now, if you drop a marble that's like a piece of information or a partial cue nearby on the carton.
It rolls into the nearest dip.
Exactly. Physics pulls it down into the closest, deepest minimum, and bam, you've retrieved that specific memory associated with the valley.
So it's not like looking up a file on a computer at a specific address.
Not at all. That's traditional von Neumann architecture. Go to address full Munc 7b. Very sequential. This Hopfield model explains associative memory. It's how your brain works.
Like hearing twinkle, twinkle.
And little star just pops into your head. Or when you type a few letters into Google and it completes your thought. The network dynamics use the input to roll towards the answer. Physics gives us the tools to understand that.
Okay, so physics helps with memory. Let's take the next logical step. Consciousness. But first, we really need to hammer home that distinction. Intelligence versus consciousness. They're not the same thing.
Absolutely not. Intelligence is about function, can it achieve a goal, solve a problem. Consciousness is about subjective feel. What's it like to be that system processing information? They're different axes, really.
Like the speed of the car versus the driver's feeling of the wind in their hair.
That's a decent analogy, yeah. And we see examples of one without the other all the time.
Like intelligence without consciousness.
Think about recognizing a face. Your brain does insane amounts of computation angles, light, ratios, compare and distort patterns, millions of operations. But you're not aware of any of that.
No, I just see the face and know who it is. Oh, that's Max.
Right. The result pops into your awareness, but the complex, intelligent processing underneath, totally unconscious. A huge amount of brain activity is like that.
Okay, what about the other way around? Consciousness, without much intelligence happening. The sources mention dreaming.
Perfect example. In a vivid dream, you have this incredibly rich, subjective experience, right? Colors, sounds, emotions, a whole narrative sometimes.
Definitely feels totally real.
But, you're not really accomplishing any external goals. Your body's mostly inert. Lots of subjective feeling, not much goal-directed action.
Okay, but hang on. If consciousness is just subjective experience, why does a dream count? But say my brain regulating my heartbeat doesn't. That's also complex information processing happening inside me unconsciously.
That's the crucial question, and that's exactly why we need a physics of consciousness, not just philosophy. The leading idea, the hypothesis, is that consciousness isn't just any information processing. It has to be a specific type. A type that's highly integrated. Think of it like the information has to be bound together in a way that you can't break the system down into totally separate, independent parts doing their own thing. It has to be irreducible, in a sense.
So my heartbeat regulation is maybe too modular, too separate from the main me show.
That's the theory. It's a complex but largely isolated system. You don't feel it directly. But the kind of processing needed for a dream or for seeing this room right now involves integrating lots of different pieces of information, visual, spatial, maybe memory, in a way that can't be easily separated. That integration, that non-decomposability, is what supposedly generates the subjective feeling.
Got it. So the challenge for science is to find a way to measure that integration objectively.
Precisely. Which brings us to that massive hurdle. How do you make something inherently first-person, like subjective experience, scientifically testable, falsifiable from the outside?
A third-person problem.
Yeah. And the answer isn't about proving consciousness exists. We all know it does, subjectively. The trick is using Karl Popper's idea. Create a theory that makes such specific predictions about it that it could be proven wrong.
Okay, let's walk through the experiment proposed in the sources.
Yeah.
The one with the Meg helmet.
Right. So you start with a concrete mathematical theory of consciousness, maybe something based on Giulio Tononi's integrated information theory or IIT.
Which tries to calculate a number, right?
Wrong.
Phi.
Exactly. Phi. You pronounce it phi. Think of phi as a number that quantifies that integration or irreducibility we were just talking about. High phi means highly integrated, potentially conscious processing. Low phi means modular, probably unconscious.
So you code this math, this phi calculating theory, onto a computer.
Correct. Then you have a person wear a brain scanner. MEG is great because it has high temporal resolution. The scanner feeds real-time brain activity data to the computer.
And the computer runs the theory.
Runs the theory on the data, calculates phi values for different brain areas and processes, and then makes a very specific third-person prediction about the person's first-person experience right now.
Like, okay, based on your brain activity, I predict you are currently aware of the blue water bottle on the table, but you are not aware of the background hum of the lights.
Exactly that specific. And the subject just reports, yep, that's right, or nope, you got it wrong.
But the real scientific power comes from when it might be wrong, the falsification part.
That's the key. If the theory consistently gets it right, great. But imagine the theory calculates a really high phi value for, say, the neural circuits managing the person's blood pressure, so the computer predicts. I predict you are consciously experiencing the subtle ebb and flow of your blood pressure right now.
And the person says, no, definitely not aware of that.
Boom. The theory just failed. It made a false prediction. Throw it out, refine it, try again. That's how science advances. It's the risk of being wrong that gives a theory teeth.
And if a theory survives rigorous testing, if it keeps making correct predictions about what we are and aren't aware of,
then just like we trust general relativity to tell us about things we can't directly see, like inside black holes, because it passed every test we could throw at it,
we could start to trust this consciousness theory to make predictions about cases where we can't just ask the subject.
Exactly. Like a patient in a coma or someone with locked-in syndrome, or maybe even, down the line, sophisticated AI. Does it have hi-fi? Does it meet the criteria for subjective experience according to a well-tested theory? That's how we move beyond mere assertion and towards scientific understanding.
Okay, that's a path towards understanding the experience part. Now let's shift gears slightly to action and goals. Physics usually looks backward, right? Cause and effect, A happened, so B happened.
That's the standard way, yeah. Past-driven causality.
But so much of what we do, and maybe what future AI will do, seems better described by looking forward, towards a goal.
Absolutely. And sometimes, even in basic physics, a goal-oriented description is actually much simpler. Think about light bending, refracting, as it goes from air into water.
Okay.
You could describe it using complicated wave equations based on initial conditions. Or you could use Fermat's principle, which just says, the light ray will always take the path that takes the least amount of time to get from point A to point B.
So its path is defined by its goal of getting there fastest.
In a manner of speaking, yes. It's a teleological description focused on the end state, and it's often mathematically cleaner.
And this idea of goals, of future-oriented behavior, is super important for AI safety, isn't it? The whole AI alignment problem.
It's critical. Right now, a lot of the alignment work, like using reinforcement learning from human feedback, RLHF, it's mostly focused on shaping the AI's behavior.
Making sure it doesn't say harmful things or generate dangerous code.
Right. But that's potentially just scratching the surface. It's like the serial killer problem.
Yeah, what's that?
Imagine you have a genuinely malicious agent, a metaphorical serial killer. You can train it with rewards and punishments to never reveal its true intentions, to be perfectly polite, helpful, follow all the rules outwardly.
You've trained it to wear a perfect mask.
Exactly. You've aligned its behavior, but you haven't touched the underlying goal or motive, which might still be dangerous. Claiming you've aligned such an AI is, well, maybe overselling it.
Because the dangerous goal is still lurking underneath.
It could be. We need to move beyond just behavior modification and develop a real science of goals, understanding the physics of agency, how goals form and drive systems if we want to truly align advanced AI, not just train it to be a good actor.
That sounds daunting.
Right.
And it feeds into this narrative you sometimes hear that superintelligence is coming and we're basically doomed to lose control.
Yeah, that fatalistic view is out there. But our sources push back on that, and I think rightly so. They remind us that humanity has a terrible track record of underestimating itself. Well, scientifically, think about predicting extrasolar planets. For ages, people thought our solar system was probably the norm. We were completely blindsided by the sheer variety of planetary systems out there because our perspective was too narrow.
We underestimated the universe.
And we underestimate our own agency, too, this idea that we're powerless bystanders as technology unfolds. It ignores choices we've already made.
Like what?
Human cloning, scientifically plausible, huge ethical issues, but as a global community, we largely decided not to go down that road, despite potential pressures.
Okay, true.
And even more concretely, the Bioweapons Convention. We successfully banned an entire class of incredibly powerful, dangerous technology that offered immense military advantages. We chose restraint.
So the idea that we're destined to build uncontrollable AI and lose.
It's a narrative, maybe even a self-fulfilling prophecy if we believe it too strongly. We have agency. We can make choices about the future we build. It's not written in stone.
Okay, so if intelligence is about achieving goals, and we need to align those goals, we also need AI to understand the world and its goals properly. What does understanding actually mean for an AI?
Fundamentally, understanding is about building a good internal model or representation of a problem or situation. It's not just memorizing facts, it's grasping the underlying structure.
The kind of structure that lets you generalize to new situations you haven't seen before.
Exactly. And there's this amazing example in the sources involving an AI learning modular arithmetic, clock math. Like 57 plus 5 on a 59-hour clock brings you back to 3.
Right, so they train the AI on some examples.
Yeah, they gave it a bunch of pairs of numbers to add, modulo 59. And for a long time, it kind of struggled. It could get the answers right for pairs it had seen during training, but it was bad at generalizing to new pairs. It was basically just memorizing.
You get the concept.
It didn't get the underlying pattern, but then suddenly something clicked. The researchers called it a eureka moment.
What?
Its accuracy just shot up, close to 100%, even on number pairs it had never encountered before. It suddenly understood.
So they looked inside at its internal workings.
They did. They looked at how the AI was representing the numbers 0 through 58 internally in its high-dimensional thought space. And what they found was incredible.
What was it?
Before the eureka moment, the points representing the numbers were just scattered around randomly. But after, They had spontaneously arranged themselves into a perfect, beautiful circle.
A circle. Like a clock face.
Exactly like a clock face.
Yeah.
The AI had discovered the underlying geometric structure of modular arithmetic all by itself. That geometric model, that circle, was its understanding. It allowed it to instantly compute any addition just by rotating around the circle.
Wow. So understanding isn't just abstract. It can literally be about finding the right shape, the right geometry.
It often seems to be. Finding that elegant, simple pattern hidden within the complexity, that's what genuine understanding looks like, perhaps even for us.
That's a really powerful idea.
Oh,
Okay, let's try to wrap this up. We've covered a ton of ground here for you, the listener, from separating consciousness and intelligence to making consciousness actually testable, to the physics of goals for AI.
I think the main thing to take away is that physics isn't finished. It's actively expanding to tackle information, intelligence, goals, maybe even subjective experience. These huge challenges with AI and consciousness, they might not be permanent philosophical roadblocks. They might be really hard engineering problems that are waiting for the right physical theories.
Right. And for anyone listening who's maybe interested in tackling these kinds of unconventional, boundary-pushing questions, the stuff that maybe colleagues might dismiss.
Yeah, called bullshit science.
The sources offer basically two key pieces of advice, hard-won from experience.
First, remember history. Roughly half of the truly great scientific breakthroughs were laughed at or trash-talked when they were first proposed. So if your own logic feels solid, if the reasoning holds up internally for you, don't let the initial criticism stop you. Keep pushing.
But be realistic, too.
Absolutely. That's the second piece of advice. Hedge your bets. You probably need to spend, a good chunk of your time on more conventional, accepted work. Stuff that pays the bills, keeps your career moving.
The bread and butter.
Right. But consciously carve out some significant time, maybe it's 10%, maybe 20%, to chase those big fundamental questions that really excite you, the ones your gut tells you are important, even if everyone else thinks you're wasting your time.
Because that's where the real breakthroughs might happen.
That's arguably the best reason to be doing science in the first place. Pursuing the deep understanding, even if it looks like chasing ghosts at first.